In this video, we will cover how to calculate estimated completion, what is the purpose of this metrics, how to use this metrics to evaluate the performance of the project. In addition to estimated completion, we are also going to learn what is meant by variance at completion. So this video will be very useful for you, and I'm going to use a brain-friendly approach to teach you. So don't feel intimidated with EVM Metrics. We're going to make it easy for you. So let's get started. Alright, now we're going to discuss about some of the EVM metrics we use to forecast the future of the project. If you take schedule variance, schedule performance index, cost variance, cost performance index, planned value, earned value, and actual cost, all those things are related to the present. So far, how we have done the things, and at the moment, how the project is doing. Are we on track, or are we having any deviation, and so on. Now there are some metrics, EVM metrics, which help us to forecast the future of the project. And when it comes to forecasting the future, well, we have 4 different metrics in EVM. These are the major forecast metrics we have in earned value management. The first one is estimate at completion. The second one is called as estimate to complete. The third one is called as variance at completion. The fourth one is called as to complete performance index. Okay, so we're going to learn about these 4 metrics. First, we'll start with EAC. We will talk about EAC and find out how to calculate EAC. EAC means, as I mentioned already, estimate at completion. Now, to calculate these metrics, we need to first understand what is meant by BAC. Okay, budget at completion. You see this point, this is called BAC. Let's say we have a new earned value management chart. This is different from what we created for the previous discussion. This is a relatively simpler one. If you look at the cost axis, y-axis, this project has in total $12 million budget. Okay, so this is the budget, the cost baseline of this project. So we have $12 million, and BAC is also called as total PV. This $12 million what we have here is called as BAC, otherwise called as budget at completion. If you take this curve, this chart, that is a blue line, we know this is the PV value, right? And the point is, if you're going to spend the money according to the planned budget, by end of the project, when you complete all the planned work, how much money you're going to spend. So that's about BAC, budget at completion. Towards end of the project, when you complete all the planned work, how much money you plan to spend? That's the question. So and the answer is BAC, budget at completion. Budget at completion is also called as total PV, because this blue line represents the PV, plan value of the project, and okay, the total amount we're gonna spend, the total budget we plan for this project is BAC. In this case, it's 12 million, and this is the same reason why we call BAC as total PV, and therefore BAC and total PV are same. So once you know BAC, now it's easy to calculate EAC. As I told you, EAC is a forecast metrics, which means we have some numbers with us at the moment. You see here this line. This indicates we are in the middle of the project. Okay, we are done with 6 months of time, and we have accomplished some work. Now we are working on calculating the EVM metrics. You need CPI value to calculate EAC. Now, first let's understand conceptually what is EAC is all about. We are here, this is our actual cost. Hope you agree with me. This is the planned value, and this is the earned value. In this case, our actual cost is, you see here, it's $7 million. It's our actual cost. And if you take earned value, this line, it's $5 million. And let's see what is the planned value here. We found it as 6 million. Okay, so this is the current situation. Now using these three values, let's calculate SPI and CPI. To calculate SPI, we know the formula. Everything starts with EV, and SPI means index, so I'm gonna do division. The next one is PV. Next variable is PV, because we're gonna use AC for CPI. Here we have C, here we have C. PV is the left out item, so I'm gonna use that for SPI calculation. EV divided by PV, EV divided by AC. Now let's calculate SPI value. EV divided by PV, in this case EV is 5 million and PV is 6 million. So 5 divided by $6 million, that will be the SPI value. And when it comes to CPI, it's EV by AC. In this case, EV is 5 million divided by AC. AC is 7 million. So let's calculate and find out these values. Okay, now I have calculated the numbers and found CPI value is equal to 0.7 and SPI value is equal to 0.8. This means this project is neither doing well in terms of schedule nor doing well in terms of cost. Both are bad. Now I need this value, CPI value, to calculate EAC. So we know that CPI value is equal to 0.7. Also we need the BAC value, budget at completion. So budget at completion in this case is 12 million. You see here the total amount of money we're gonna spend to complete this project. So that would be our BAC. Alright, so we know the BAC, it's $12 million. Now let's calculate EAC. Now EAC is all about how much money we're gonna spend towards the end of the project if you're gonna continue the current rate of expense. So you are spending money at this rate. The current rate of expense is this. You see here, this is the current rate of expense. You are spending a lot of money. In this case, this is your earned value. This is your actual cost. You see this delta. This indicates you are spending more money than what you actually earn. The worth of work you accomplish is much lesser than the amount of money you have spent. Alright, and if this trend is going to continue like this, towards the end, how much money we will spend? By end of the project, how much money we will spend? So this projection, this number is called estimate at completion. Alright, we say estimate at completion because what you anticipate, if you're going to continue spending money at this rate, by end of the project, how much money we will spend. Definitely in this case, it will be greater than the BAC because here you see the actual cost is above the planned value. Okay. Now your management is curious about this number. We always expect the EAC value to be very close to BAC or equal to BAC. The best case is if the EAC value is below the BAC value, we'll really celebrate. It's a very good situation. Okay, however, in this case, because the rate at which we are spending the money is more than the planned budget, amount of value we earned in this project is lesser than the amount of money we have spent. Okay, so finding this is our objective. However, the question is, Ahmed, should I need to extrapolate this line manually to find this number? The answer is no. we have a formula for EAC. Remember, EAC is same as BAC, but it is influenced by the current rate at which we spend the money, the way how we are spending the money. If the trend is going to continue, what would be our new BAC? That's about EAC. So we need to take the BAC value and influence that number with the CPA value, because the CPA value represents the rate at which we spend the money at the moment. So I'm going to take the CPA value and BAC value to compute EAC. So EAC is equal to BAC value divided by CPI. When we do this, we get EAC value. In this case, it's $12 million. I'm going to divide this by 0.7. That's the current CPI value. Now, how much you're going to get here? Roughly, we get $17 million. Okay. So that's our EAC. Therefore, I'm going to put this number here. So if we are going to continue spending the money at this rate, the current CPA rate, then we would need $17 million to complete the project. Now, the moment you tell this to your management, people will not feel okay about this. It's because there's a huge variance between the originally planned budget, that is BAC, and the forecast we made, the EAC value. If it is close to BAC value, people will be okay. Otherwise, we are expected to take some action to bring down the expense, and the management would expect you to do something so that the trend will correct itself and become something like this. Okay. Ideally, this is what expected from us. So we need to take some corrective action here. I won't call this as corrective action. We should call this as preventive action, because whatever action you take to fix problems you foresee in the future, those are called as preventive action, otherwise called as improvement action, not corrective action. Okay, preventive action. And we need to implement the preventive action, then demonstrate that in the upcoming EVM analysis, we are actually changing the trend, and most likely the ECA value we're going to calculate in the future is close to or matching the BAC value. All right, that's about how we compute EAC. Let's say in your project the CPA value is 1. This means your actual cost and earned value are equal. The amount of money you have spent and the amount of the worth of work you have accomplished in your project are equal, and that's why you get CPA as 1. Now if you supply CPA equal to 1 in this formula, you're going to find this. So 12 million divided by 1, you're going to get same. Alright, so therefore if you have CPA value is equal to 1, this means your EAC and BAC will be same. You don't have to take any preventive action, everything is okay. Let's say your CPA value is greater than 1.3. This means you have achieved more worth of work. Your EV value is greater than your actual cost. Right? So let's say EV divided by AC is the CPA value. If the numerator is greater than the denominator, only then you get values greater than 1, like 1.3, isn't it? So if you look at this graph, the delta between these two it's all about the CPA value. Okay, this is your earned value, this is your actual cost. Now we are calculating CPA based on EV divided by AC. If the EV is going to be greater, this means, let's say you have a trend like this. Instead of this green line, okay, we have a new green line and it looks like this. All right. Now, if you look at the delta here, the new AC value is lesser than the earned value. The earned value is greater than the AC value. This means the CPA is going to be bigger, greater than 1. And in that situation, if you make a forecast how much EAC going to be, then definitely it will be below the BAC value, right? Are you clear? So CPA value will influence the EAC value. The takeaway is, if CPA value is equal to 1, then EAC and BAC value will be same. If you have a CPA value which is greater than 1 like this, then your ECA value will be below the BAC value, will be lesser than the BAC value. In case if you have a CPA value which is lesser than 1, for example, in this case we have 0.7, then you're going to see a trend like this. The EAC value will be above the BAC value. I hope you are clear with the EAC calculation. And there are 3 more methods to calculate EAC value. We'll talk about them later in this lecture. Before that, we will learn about few more forecast metrics. Now assume that you have this EAC value and this BAC value. Let me clean up the board for you. The next forecast metrics we're gonna learn now is called as Variance at Completion, VAC. Well, once you know the EAC value, you can tell what is the delta between the originally planned BAC value, that's our actual plan, and the newly made forecast value, EAC value. So this delta, the gap between these two values, EAC and BAC, is called as variance at completion, because we're talking about when you complete a project, this is the original budget we planned to spend, and now we made a forecast based on the current CPA value, and we found that it's gonna be 17 million. So the delta between these two is called as VAC, variance at completion. Okay, so to calculate variance at completion, we need to first take the BAC value and subtract EAC value from it. BAC minus EAC will give us VAC value. In this case, it's 12 million minus 17 million. We got minus $5 million. Okay, that's our VAC. Just like the SV and CV value, if you get a negative value in VAC calculation, this means things are not good. Look at this picture. You're supposed to complete a project with the estimated budget of 12 million, but you now anticipate you might spend around about 17 million. This is actually guesswork. You are making a forecast how much money we're going to spend in the future considering the current CPA value. Based on this, you found that we're going to spend 5 million more than the originally planned budget. That's the forecast we made now. And that's about VAC value. You get a positive number, then it's going to be okay, because it's something like this. Your CPA value is greater than 1, like 1.2 or 1.3. In case, so you might have a, EAC value somewhere here. In this case, you get a positive delta. Let's say this is 7 million. Then if you go for 12 million minus 7 million, you're going to get 5 million, positive number. This means good. You are seeing a good future. The value, the amount of money you will spend towards the end of the project would be lesser than your total planned budget. If the CPA value is 1, then the BAC and EAC value will be the same. Alright, so that's about VAC. With that, we are done with this discussion. I hope you liked this discussion. If so, please give me a thumbs up, and also you can subscribe to my channel, because I regularly come up with a lot of useful project management videos. So you can subscribe to my channel to learn project management at ease. Also, if you have any idea to take any project management training, including PMP, you can register in our bootcamp. We have excellent reviews and ratings for our training. Also, we offer this training for very affordable pricing. The best part is you can attend the first 2 days of the training, that is first 10 hours of the training, for free to enjoy the training, to assess its quality. If you find the training useful and effective, then you can continue with us. The link for registering in our bootcamp training, PMP Bootcamp, is in the description. So please go and register if you're interested. I will meet you again with another interesting and useful video. Thanks for watching this video. Bye-bye.